Hello and welcome to Three Questions with. Got my friend Laurence with us today. Good afternoon, Laurence. Welcome to the show.
Thank you. Hey, Kevin. How you doing? Appreciate you taking the time today.
Everything's great, bud. So, Laurence, I've seen some of your posts and you talk a lot about power quality. I'm not really sure what that is. Can you just give me a little overview of
Sure.
what it is and why it's important?
Yeah, when we talk about electric power quality, is usually, to be clear, when we're talking about electric power quality, it's the more technical definition is the ability of an electric distribution network or an electric system to supply power per specification, whether it's 480 volts or 110 volts in a house, supply power to the loads that are using it consistently, reliability, and according to design specifications. So when we talk about power, where we live in the industrial arena, so we'll talk about industrial settings, and it's usually either 240 volts, 277 for lighting, or 480 volts, three phase. And so when we talk about power quality, we talk about or lack thereof. Power quality issues will manifest themselves in the voltage is unstable. I mean, that's everywhere to one extent or another. But obviously, if in an ideal world, you'd look at a voltage graph and it would be a complete flat line 480, and the current's going back and around and the average stays right there. It doesn't in life. So voltage instability is a big issue. And when voltage is unstable or unreliable, obviously motors aren't getting the supply they need. They don't have the torque that they need. They struggle to start up, or when the load changes or increases, all those things. That also manifests itself in current being a lot higher than it needs to be for a lot of reasons. But for whatever the reasons are, whether it's harmonics, pollution, multiples of 60 hertz that fly around on the network, whether it's things being imbalanced across phases, and I don't want, this isn't the time to get into the electrical weeds, but there's all kinds of phenomena which will lead to higher current having to flow through the system in order to get the motors the power that they need. Higher current means more loss. That's just physics. You can't argue. The physics don't lie. More current means higher heat loss, more distribution loss. Things that heat up more, they wear down more often, causes more interruptions, more faults, and the long litany of problems. We often use a metaphor of a bicycle. It's a really simple machine that everybody's familiar with.
Yep.
If you're pedaling real hard and you could be a great athlete, but if the frame of the bicycle, which is the distribution network, right, that's transferring power from your legs to the wheels and to the friction on the pavement, and it moves the bike forward. If that frame stretches or twists because it's not high quality, then you're putting power into stretching the frame and not moving the bike forward. If the bearings in the bottom bracket of your bicycle are shot, you're going to get vibrations, and if you could, all those vibrations are being transferred, and obviously, they're getting in the way of useful power being transferred to the wheels. If the pedals are, and this is a very literal metaphor, if the pedals are out of balance, I mentioned imbalance across the phases. If the pedals aren't machined really well, they're not high quality, and they're a little bit not 180 degrees from one to the other, then again, you're going to have to supply more power to get the power you need to get that bicycle to move at the speed you want it to. All those things come into play in an electric distribution network, I should say, and all the attached motors, and that's what we want to address.
So then thus I would have higher costs because of this efficiency?
Absolutely, because what happens is, I'll continue a metaphor with a little bit more sophisticated machine. Let's talk about a car or a vehicle. Now there's electrical vehicles coming into play and people talk about batteries, but in a traditional internal combustion engine vehicle, fuel economy has been a metric that everybody's familiar with. It's been around for 100 and some years, right? And everybody understands that what can get in the way of fuel economy. Obviously, you want a good fuel pump. Used to be when cars were cars, you had carburetors. Now you have fuel injectors. But still, a lousy carburetor is going to be unreliable. It's going to be inconsistent. It gets stuck too open or too closed. How is that going to, everybody would tell you, is that going to affect your fuel economy? Yes, you're going to pay more for gas. You're getting lower mileage. So to go 100 miles, you're going to pay more. And the metaphor is very literal. If you're having more, you have to compensate for all those power quality issues by having to supply larger amounts of power and much higher current levels, more losses, more vibrations, more things getting in the way. Motors have to work harder. Yes, that's money. It's money bottom line. A huge piece of the puzzle that doesn't get talked about enough, I'll add, is the wear and tear on equipment. Think of things vibrating. Again, think of your car. yes, fuel economy will go down, but also your filter or your fuel pump's going to die in 1 year and not in 2 years if it's working too hard. That's money too.
Yeah.
So I hope I answered your question.
Yes.
It's a lot of money. That's right.
Yeah. So is electric power the primary focus of Energy LB? Because you seem to know a lot about it.
It's one of our core areas of expertise. I come from the electrical engineering background myself, and my partner does. But so it's a core area, but it's certainly not the only area. To continue the metaphor, if you want to improve the fuel economy in a vehicle, I'm kind of stretching this metaphor hard today, but it works for the conversation. If you want to improve the fuel, sure, you want to look at the fuel pump and the fuel filter and the quality of the fuel itself, right? That's a starting point. But if your wheels are out of alignment, that's going to reduce your fuel economy, and you have to supply more fuel and pay more to go that same 100 miles. So you're going to want to align the mules. If the engine's not mounted correctly and you got vibrations going through the whole, into your tie rods and into the wheels and everything else, again, is that going to affect your fuel economy? Everybody would say, your mileage is going to go down. Yep. It's going to cost you money, and it's going to be more wear and tear on the car. So bringing that back to reality, sure, we're going to look at the electric power, but maybe there's huge chilling systems that have water loops or water glycol loops or whatever the refrigerant loops are that are involved. If we can increase the thermal transfer of those systems with a variety of technologies, the pumps have to work less hard. The condensers don't have to work as hard. The compressors in those systems don't have to work as hard. Money and wear and tear and the optimum performance is going to go up, just like mileage.
So, Laurence, how does this all tie in to sustainability? A lot of companies really focusing on sustainability, carbon footprints, all that.
Right. How's that play in? Well, in the most direct way, using less is better for sustainability, right? If we can all consume less, I like to use the term consuming smarter. You're paying for a kilowatt hour of electricity. You're paying for X kilowatts of electricity in a certain amount of time. Use that in a leaner fashion. Obviously, using less and using resources smarter is in a direct way more sustainable. We've used less carbon fuel, or any fuel. Even if you have a renewable system, if you can consume less, then you have more available to put someplace else, and the world doesn't have to produce as much.
Yep.
So that's in the most direct sense. That's the obvious way. But the aspects of that are not often talked about. Again, we live in the industrial world. It's not so much a residential relevant point, but in large buildings, hotels, obviously manufacturing settings, arenas, things like that. When you improve the power quality, the power coming from the grid into that facility is reduced dramatically. The customer itself, the company itself, that business may or may not see that much reduction in power and cost, 10%, 20%, whatever we can do. But the reductions in power that has to be fed into that facility can often be twice that much. You're looking at 50, 60, sometimes 100% the amount of current, not quite that much the reduction in power, but all that power does not have to be fed into that facility because it doesn't have to overcome and compensate for all those losses. And so think about if every factory in Massachusetts or every factory in New Hampshire or every factory in New England or the country or anywhere in any region you want to talk about could say, hey, we dropped our draw from the grid by 20% or 40%. That would be a miracle. Well, that's the kind of reductions that we can achieve. And so even if the company itself isn't going to pay that much less in their bill, but they've done those steps in order to make the grid less strained, more reliable, and able to perform better in a regional sense. So those are huge decarbonization achievements.
So, Laurence, what's the best way to reach out to you? How can people learn more if they have questions?
Obviously, our website, energylb.com, and you can get all the contact info there, but our number is 603-275-7238. Contact at energylb.com. All the information is there, and that's the best way.
Awesome. I think. Laurence, appreciate you taking a few minutes to call into the show, and as always, thanks for being my friend.
All right. Thanks, Kevin. Appreciate it. Take care, all.